All right, so here we're going to talk about Pythagorean theorem and Pythagorean theorem inequalities. So first off, Pythagorean theorem says that in any right triangle, so given that we have that right triangle already, the square of the length of the hypotenuse, I'm going to call that C, is equal to the sum of the squares of the lengths of the legs. We're going to call those A and B. So A squared plus B squared equals C squared. The converse of that says if this relationship is true, then we have a right triangle. Given that that equality is actually true, given these lengths, then that must be a right triangle. So this is a proof of Pythagorean theorem. There are a ton of proofs of Pythagorean theorem. I just picked out one of the kind of nicer ones, the easier ones to understand. And actually it's by a former president, so if you're interested in watching that, you can. That video is completely optional. So I'm going to show you how to solve one of these problems, and then let you solve the other three. I'm also going to talk about Pythagorean inequalities in a second. We have this right triangle ABC, where C is the right angle. AC, I'm going to just say that this is A, is 5 times the square root of 2. AB is 2 times the square root of 15. Find BC. So we know that A squared plus B squared equals C squared. So we know that our C is our hypotenuse across from the right angle, so that's 2 times the square root of 15 squared. I'm going to just call this B and leave A squared by itself, thinking of this as A. And my B is 5 times the square root of 2 squared. So my exponent rules say that I can actually distribute this exponent into both of these, which is what I'm going to do to make this a little bit easier. Square that, and square this, and square this. So A squared plus, this would turn into 25. This would turn into just 2. So that's 50. That is 5 times 5, 25. This is the square root of 2 times the square root of 2, which is just 2. That's where I'm getting that 50 from. Same kind of thing here. This would be 4 times 15, or 60. So I'm going to subtract 50 from both sides. Get that A squared is 10. So A, or this length, BC, is the square root of 10. All right, so you should be able to do those other three on your own. So here I'm just going to talk a little bit about the Pythagorean inequalities theorem, which actually has two parts. It's basically saying that based off the Pythagorean theorem being true for right triangles, if C gets too big, then the angle that's opposite C also gets too big. It's no longer a right triangle, it becomes an obtuse triangle. If this side is too large, if that C squared is greater than A squared plus B squared, then this is an obtuse angle because that grew. If that shrinks down a little bit, then this shrinks down a little bit, making that an acute triangle instead of a right triangle.